In this video, we will look at what are graphs, its definitions and properties. Graph is a representation of relationship that exists between objects. Graph is a collection of objects along with a pairwise connection between the objects. For example, let us consider this map of road network, where cities are represented as objects and the pairwise relationship between objects are represented by roads which connects two cities. So this forms a graph of cities and roads connecting the cities. Now in terms of graph terminology, we call the objects, that is in this case cities, as vertices and the pairwise relationship between objects as edges. Let us look at another example of flight network, where airports are represented as objects or vertices, and the flight paths are the relationship between objects or vertices represented by edges. Let us now formally define a graph data structure. Graph is a collection of objects called as vertices, together with the relationship between objects called as edges. So a graph G is a set V of vertices and set E of edges, which contains pair of vertices or simply an edge in a graph joining two vertices. The vertices are sometimes also called as nodes, and even edges are also sometimes called as arcs. But we will be using the term as vertices and edges throughout this section. Let us look at a graph. Here we have four vertices, that is vertex A, B, C and D. So here the set V of vertices is A, B, C and D. And the set E of edges contains 5 edges, that is an edge from A to B, A to D, B to C, B to D, as well as from vertex C to vertex D. So we represent graphs in terms of set of vertices, that is V, and set of edges, where edge is a pairwise relationship between the vertices. So now that we have seen the formal definition of a graph data structure, in the following videos we will look at different terminology that is used in graphs. A graph may have different types of edges. An edge may be a directed edge or an undirected edge. An edge from vertex U to vertex V is directed if the pair U, V is ordered with vertex U preceding vertex V. A directed edge has orientation, that is, the edge has a direction. If all the edges in a graph are directed, then the graph is a directed graph. The directed graph is also known as a digraph. An edge is undirected edge if the pair U, V is not ordered. An undirected edge has no orientation. If all the edges in the graph are undirected, then the graph is an undirected graph. The graph which has both directed and undirected edges is known as a mixed graph. The edge in a graph can also be a weighted edge. If a cost or a weight is assigned to an edge, then the edge is known as a weighted edge. If all the edges of the undirected graph have weights or cost assigned, then the graph is known as a weighted undirected graph. If all the edges of the directed graph or digraph has weights or cost assigned, then the graph is known as a weighted directed graph or a weighted digraph. The two vertices joined by an edge are known as end vertices or end points of the edge. For example, in this graph, if we consider an edge between vertex A and vertex B, then vertex A and vertex B are end vertices or endpoints. If the edge is directed, the first endpoint is the origin, and the other endpoint is the destination of the edge. For example, in this graph, an edge between vertex A to vertex B is a directed edge. So, vertex A is the origin and vertex B is the destination of the edge. Two vertices are said to be adjacent if there is an edge between them. For example, in this graph, there is an edge between vertex A and vertex B. So, vertices A and B are adjacent vertices. An edge is said to be incident to a vertex if the vertex is one of the edge's endpoint. For example, an edge from vertex A to vertex B is incident from vertex A and incident on vertex B. In the same way, an edge from vertex B to vertex C is incident from vertex B and incident on vertex C. The outgoing edges of a vertex are the directed edges whose origin is the vertex. The incoming edges of a vertex are the directed edges whose destination is the vertex. For example, an edge from vertex A to vertex B. This edge is an outgoing edge from vertex A, an incoming edge on vertex B. In the same way, an edge from vertex B to vertex C. This edge is outgoing from vertex B and incoming on vertex C. In the graph, an edge is a self-loop if both the endpoints are same. For example, in this graph, if a vertex A has an edge originating from vertex A and the destination of the edge is also the same vertex, that is vertex A, then it is called as a self-loop. In a graph, edges are parallel if there is an edge between vertex U to vertex V, as well as there is an edge between vertex V to vertex U. That is, there is an edge between vertex U and vertex V, as well as there is an edge between vertex V to vertex U. For example, in this graph, there is an edge between vertex A to vertex D, as well as there is an edge between vertex D and vertex A. So these edges are called as parallel edges.